Yeah. Okay, I restarted recording this time. Uh, our students aren't here yet. We have two new students.
Oh, that's great.
Yeah. Uh, could you turn your mic up a little bit?
Yeah. Is it better?
Yeah, that's better.
Okay.
Uh, can you hear me?
Yeah, I can hear you.
Okay. Um, yeah, they're from. I don't know whether they'll be here today. Yeah. No, they are.
They just
I just saw. Uh,
That's
so
like an airport, man.
hold on.
And you are live right now. I did not bring my laptop. You need to bring your laptop.
Hello,
I need to get you guys on.
Mr. Douglas.
I'm Ryan.
Hi, Ryan. And
Is it good for you to introduce yourself?
Oh, uh, yeah.
Introduce yourself. Means
I'm Logan.
There you go.
Logan Lawrence.
Logan.
Hi, it's nice to meet you.
okay, I thought, is Lawrence your last name?
Yes.
Got
Yeah.
it. I think she has it backwards.
Really?
Okay. I'll make sure that's right, Logan. And Walter.
Yeah, hi, I'm Walter.
He's Walter. And hi. Okay, Ryan and Logan. Are you guys both seniors?
Yes.
Yes. Okay. Welcome. So we're today. Walter has been with me. This is his second week, and let's just spend a minute, a minute or two introducing ourselves. So, Walter, can you say what school you're from and a little bit about your and the math you've taken and what interests you have?
Okay. I'm Walter. I go to Canterbury School in Fort Wayne, Indiana, and I've taken math through multivariable calculus, and I don't know, a lot of things interest me, I guess. I play soccer.
And cello.
Yeah, and cello.
Okay, Ryan.
Um, I go to Fort Worth Country Day. I'm a senior. I've taken up to AP BC Calc. That's what I'm in right now. I thought this would be nice.
Okay.
I don't do any sports right now. I used to run cross country, and I don't really play any instruments.
That's all right. Well, whatever. It could be whatever. You like to hang out with your friends. That's fine too. Okay. So you like math, I take it, taking 2 math classes.
Mm-hmm.
Yeah, great. And Logan?
Same here. I'm a senior from Fort Worth Country Day. I play the violin.
Okay.
Yeah, I do that a lot. It takes up most of my time. But I also do year-round tennis.
Oh,
So
good for you. All right. And math, just tell me what math you've taken.
I'm in BC Calculus right now. I don't really know what I want to do, but I definitely want to get started. So
Okay, great. Sounds good. Let me ask you one quick tech question too, which is, do you guys have PCs or Macs?
PC.
PC.
PC, okay. So we all have PCs. They all have PCs. I do a Mac, but it's fine. And you have Word, you have Office, I take it? Microsoft Office? Yes?
Yeah.
Yeah, okay. Good. Because I'm going to send some and DocX, the latest one, the DocX files that you can add to. That makes it easier. Okay. We're going to have to set up, Ryan and Logan, we're going to have to set up a time and where I catch you up. Okay. And so why don't you, I copied you on an email. I'll send you another one with lots of, that I sent to Walter, but I'll send you directly with an email with my, email address and stuff. And I'll ask you what's a good time between now and Friday when we can get together. Okay? Can you make some time for that?
Yeah. Yeah.
Okay, sounds good. All right. So today, you're just going to be watching more and getting familiar, and then I'll send you all the stuff, and I'll when we get together, I'll give you the background that I've given to Walter. Okay. So Walter, let me direct this to you a little bit. I got your homework, and I'm sorry about that file. The problem with the file was I put a triangle symbol in the file name.
Okay.
Yeah, and so it didn't understand that. So I reloaded it and I sent it to you. I put the word triangle in the file name. So for next time. Also, you're right. I forgot to upload the topic list. You did give me feedback, but I did upload it now, and I'll put it on the homework for Friday as well.
Okay.
So if you have anything to add, and then we'll decide all together. And for Ryan and Logan, I'll tell you that the first 3 weeks of the class, I set more or less, but this is very much your class. So there is a choice of topics, and we can't do all of them. So I'm going to want your input on what you think, what's interesting to you. Walter's given me some. And if you have other suggestions, the only condition is, it's got to be some kind of advanced math topic that is related to geometry, because it's called Advanced Math Topics Through a Geometric Lens. So how to use geometry to either do some geometric topic or in depth, or use geometry for something else, but a visual kind of lens. Okay, that's basically the condition, and we're all okay. So we're all at least in BC Calc. So that tells me something useful too. I'm glad we're more or less on the same level. Okay. All right. Do you all, Ryan and Logan, had you taken an MSON online class before, or is this your first one?
This is my first one.
Same here.
Okay. All right. So I'll have to introduce, when we get together, I'll introduce you. So I'll just send straight email for now, and then when we get together, I'll introduce you to the other parts of it. Walter did take one in the fall, so he knows the ropes. And you guys will all have your emails, so each other's emails. So feel free to communicate with each other too. That's useful. Okay. Okay, did that. Right. Okay, so we've been working with some software, and this is free software. It's called GeoGebra. Have you guys heard of it? Okay, so it'd be new to you. And it's very powerful stuff, and it's free, amazingly. It used to be, there was Geometry Sketchpad is what, it's called Dynamic Geometry Environment, and there were two major programs that originally cost a fair amount of money, Geometry Sketchpad and Cabri, which was done in France. And as usual these days, that there are people who worked on it for nothing. Well, and how they do that, I don't know, but it's available. So we've been doing some work on that. Oh, the other thing I want to say, Walter, this is to you. In the past, we've sort of been discussing the homework a little bit during class. Actually, it's all three of you. But I'm realizing that since, it's due like an hour before class, and now that we have three people especially, it's better if you just send it in, and I'll just take any questions, and then I'll make comments on your particular assignment and send it back to you individually. So everybody will get some comments on that. But it sounds like it was pretty straightforward for you. I did look very quickly at it. All right. So today, what we're going to do is demonstrate the transformational definition of congruence with a file first that I'll use, and you'll help me through, and then and then you can try one. I sent you a file recently, and we can do that shortly. I'm hoping that I'll also have to send Ryan and Logan the links to various. We have 2 Adobe Connect classrooms, and one for Tuesday, one for Friday. So we're using the Tuesday one today. And Walter, we were working with a whiteboard last time. I think you can share a screen through Adobe Connect, that it's more participatory, but I'm not sure I remember how to do that yet. So
I think you just add me as like a presenter or something.
Yeah, that's right. I have to make you a presenter. That's right. But first, let me demonstrate that, and then let's try. Let's see if we can make you the presenter, and then you can show us how to do something similar. So I'm going to share my screen now. And also, right now I'm just using my laptop, but I did get a monitor, and by Friday it'll be set up, so I'll have 2 screens, and that'll make it easier. I already had ordered it, but they sent it defective version, so I had to send it back. All right, so I'm going to share my screen. This also works. This also just not works. This is a piece of information for Ryan and Logan, and that is I want you to bring you both have laptops, right? Yeah. So please bring them every class, and we'll work on it being interactive and sharing our screens. So I'm going to share my screen now. Okay. And I'm going to open GeoGebra. And I'm going to open a file. Not a recent one, I guess. Yeah. And hold on a second. 15th class. Yeah. Let's do since we're starting off slowly, because we have some new people, I'm gonna do a simple one first. So I have 3 triangle congruence files, and this one is just the first one. So I want to open that. There it is, and I'm going to make a full screen. So my first question is, can you see that? Can you all see that?
Yes.
Okay. So a convention that I'm using is this is pretty easy, but it'll give the other folks a chance to get used to things a little bit. Ryan and Logan, the new people. So the convention that I use, I got from my colleague, Henry Picciotto, who is a terrific teacher, is orange for original and indigo for image. So this is the original triangle, and this is the image triangle, and I want to confirm congruence. And the definition, the transformational definition of congruence is not the usual one, which just applied to polygons, which is angle measures equal and side lengths equal, because that doesn't tell you whether 2 ellipses are congruent, for example. So the transformational definition is very nice. It's can you find a sequence of isometries, and an isometry is a distance preserving transformation that maps one onto the other. What would this one be, Walter?
A translation.
Yeah, that one's easy, and we can do a translation. I'm gonna get the third one up that has all 3, where you have to do all 3. So I'm gonna close this one, which was silly, because unfortunately with GeoGebra, if you close a file, the last file, it closes the whole business. And you have to open it again. Anyway, when you open it, you get these things. There are these perspectives on the right, and we're going to geometry. And then, of course, the green makes a full screen. But first, I'll open Cancel this. I want to open something, doesn't it? Do you want to save your changes? No. Okay. All right, there we go. The third one, which uses all three transformations. So this one's a little harder. All right, so we make a new screen. And here's the original, and here's the image. And so I want to get from the original, and everybody can think about this. This is useful. From the original to the image using, and Ryan and Logan, you can see the screen?
Yes.
Yeah.
Okay, good. All right, so I want to get from the original to the image using some basic transformations, which are translation, reflection, and rotation. So Walter, since you're familiar with this, tell me how to start. You know what I'm going to do? I'm sorry. I'm going to show the label. What I'm doing is right-clicking or control-clicking, and I'm going to show the labels here. So that's C, and this is A. Did I do it? No. This is A, and this is B, and then I have to go to my Move tool. It's my selection tool. If I want, I didn't do the B. If I want to move. If I want to move the labels to show them. Okay, so now we can refer to A, B, and C. So what do I do, Walter? What's the first thing you want me to do?
So you can rotate the triangle about vertex C clockwise. By some amount. I don't know the exact
Well,
amount.
I need to know.
You can rotate it about C, and then basically it's just a rotation, a reflection, and then a translation.
Okay, but which one am I going to do first so that I know? Because if you tell me to rotate, I need to know the point and the angle and the direction. If you tell me to reflect, I need to know the line. If you tell me to translate, I need to know the vector. So
Okay,
I need to know all three things, all things, or not necessarily three, in order to do it. So the order is important in terms of knowing the things.
So you can translate point C to point C prime.
This point here?
Yes.
All right, let's show the label here. Let's see what it says. Oh, it doesn't have a good name. Okay, so I'm going to hide it. Yeah, but this point is what you're talking about, right?
Yeah.
Okay, so I need to make a vector. So the vector is under this is the one-dimensional tools here. So I'm going to go down here and make a vector. And I'm going to make a vector from here to here, right? Right, Walter?
Yes.
Okay, so we do that. And then here are the transformation tools. And I have to go down. So I click, and the lower right corner shows me that. And I go down to translate by vector. And when I hover over, so I'm doing this a little more, Walter, I know, but just for Ryan and Logan. So when I go over here, it says translate by vector, and it tells you what to do. Select the object to translate, and then the vector. So I want to select, sometimes if you do it in the other order, it works also. Okay, so that's my first isometry. Good. So here we are, and notice how it shows that it's A prime, B prime, C prime. So that's nice. All right, next.
All right. So you can rotate triangle A prime, B prime, C prime about vertex C prime such that B prime hits the.
Yeah, I need to let me label this point.
Yeah.
Okay. So this angle B prime CH?
Yeah.
Okay. So I need to specify that angle. So here it says, so I think I need to make the angle. Yeah. And this is here, an angle, select 3 points. So I need to make the angle so it has a name. So I'm going to pick the angle tool, angle, and so this point and this point. What did I do wrong?
Oh, it's the wrong way.
It's the wrong way.
I mean, yeah.
So let me undo that and do it again correctly. I have to do because it always goes counterclockwise, which is the positive direction. Okay, so now I have my angle, and just to show it also gives you that, and it has a name, and its name is angle alpha. Okay, I can well let's see, the label is shown. Okay, but it's angle alpha, so that's its name. We're going to need to use that. All right, so now I want to rotate. That's what Walter told me to do. So I'm going to rotate around a point, and it tells me to select the object, then the center point, and then enter the angle. So here's the object that I want to rotate. Here's the center point. And now it says 45 degrees, but this is nice because here's the angle alpha, I believe. And I need to select that. Oh yeah, it gives me the list. And so I want angle alpha, which is what it named here, not 45 degrees. I need to erase that. And which direction?
Clockwise.
Clockwise. Okay, so there it is. Okay, so there's A double prime, B double prime, C double prime, and finally
reflect A double prime, B double prime, C double prime by the line,
right.
B double prime, C double prime.
Right. So it says reflect about a line, and I need the line of reflection. Well, I think it'll do the segment. I think I can use a segment. So here's the object, and here's the segment. Bingo. And it's a little off, and I'm not sure why. But the nice thing about so for Ryan and Logan especially, the nice thing about this, that's not what I meant to do, is I have to go back to the move tool. That's important. And I can move things around. So I can change, I think. Okay, what am I doing wrong here? Or maybe because this is the original. Everything's based on this. So I have to, but I can move the triangle around. And now there was I must have selected the wrong point here. Right?
Yes.
Okay. So when you do it, you'll do it better. Okay. Because there was a B double prime and there was an H in there. They weren't the same. Okay. But you get the idea. All right. So now I sent you, Walter, I'm hoping you can share your screen. So using Adobe Connect. So I'm going to close mine.
Okay.
I don't want to save it. And I'm going to stop sharing. But I think we have to do this through Adobe Connect. So let's see if this works. So we're playing around here. I'm still learning because this is my first time. So there's another way, another entry point, another piece of software called Adobe Connect, and I'm going to go there. I need to share Walter will share his screen. But there's something called Adobe Connect, and right now I'm on the whiteboard. So I guess I stopped sharing. I need to make you a presenter, Walter. So can you log into Adobe Connect?
Yeah.
Tuesday class?
Mm-hmm.
Okay, I don't see you yet. I just see me. Are you in?
Yeah, I'm in.
Okay. All right. There's a breakout room view and there's a attendee status. Okay.
Uh,
No, that's just a status.
Apparently,
All right.
I'm the only one in this room.
Oh, I'm pretty sure I was in the Tuesday room. Okay, let me. Is it R6? Yeah, it's R6, right? R6
R3.
QT, etc.
R3 and V2.
Oh, okay.
Um,
I had it backwards. R6 is the Tuesday room.
okay.
Can you go into the R6 room, the other one that's
Yeah.
I guess named Friday? But I'll correct that because I got corrected by originally I was wrong.
Okay.
There you are. Okay. And I need to make you a presenter. Make a presenter. There we go. So I select you, and I'm going to make you a presenter. There you go. So now you're a presenter.
Uh-huh.
Okay.
So,
And do you know how to share your screen now?
no, I do not.
Okay. I'm going to stop sharing mine because I have a stop sharing. There we go. And then it says, let's see.
I need to install a plugin.
Oh, okay. All right. Let's wait for that.
Okay.
Yeah, because when you first get in, it says share my screen. So I think you can do that. All right. If we can't get this to work this time, then we'll play with it and do it next time. And you'll just tell me what to do. But it'd be great if you could share your screen.
We might be able to. Do you think?
Bros, I think.
Pros. Okay. Let's practice this for next time, Walter. Okay.
All right. Okay.
Okay. So I'll go back to Blue Jeans because so there is a share your screen facility, and that's what I'm going to want to do. So the very beginning next time we'll practice this, and I'll send you the correct links so you can you can change your names, when you save it. All right, so you'll just tell me what to do. So I'll go to GeoGebra again, and maybe the other guys can tell me, Ryan and Logan this time.
Wait, I think I got my screen to share.
Oh, you got your screen to share. Better.
Yeah.
So I'm going to close this,
Okay.
and I'm going to go to Adobe Connect. Yes. Walter. Yeah, you're a presenter. Okay.
It says my screen is being shared.
Okay. Can you open GeoGebra?
Yeah.
There we go. Okay.
Okay.
Yeah, that's the quad similarity file. I want you to do the quad congruence file. Can you open that in GeoGebra?
Yeah.
I think that. Yeah. Except it's not connecting to the internet, so I don't know. Really? Yeah.
There it is. And then make it. Can you make it as Does it covering your full screen?
I can't really open it right now. I'm trying to open it still.
Oh, okay. It showed, I thought. Oh, that's the similarity. Oh, there you go. Open. Okay.
Yeah.
There it is. There.
Yeah,
Got it.
actually. Good.
There it is. Great. Okay.
That's clever.
All right. Walter, can you label the vertices of the, just because I realize that we want to have the name. So can you label the vertices there? Yeah. And then move them around so we can see them using the move tool once you label all of them.
You want me to move the vertices around?
No. I want you to move the labels around. So just the labels. If we can't see them, like L or something is a little hard to see.
How do you move the labels?
You once you have the move tool, you should just be able to grab it.
I know.
Oh, really?
Yeah. Okay. There it is. There it is. Yeah.
Yeah, go for it.
Okay. So adjust your zoom so that we can see both the original and the. There you go. Good. Okay. Okay. So Ryan and Logan, these are. I claim these are congruent, and I want you to, one of you, to tell us what to do here. How do I confirm it? I want a sequence of isometries that take the orange one onto the indigo one.
Can we get it on the screen?
Oh, you can't see it? Okay.
No.
Oh, that's no good. All right, let's see. Did you get into Adobe Connect?
Not yet, no.
Okay, so that's what you have to do.
Yeah.
I sent you guys the links, I think. If I didn't, I'll do it again. Let me,
I think you did.
Yeah, okay.
There we go. You got it?
So this is the one that's Tuesday class, and it should say the code starts with R6.
Yeah. Are you on your school email?
Yeah.
Cool.
Yeah, you're right. I don't see your names here.
Oh, not bad. Oh, I saw you download this too.
Yeah.
Oh, sweet, thank you.
I'm in the wrong one.
Yeah, it's okay if it takes a little while. Do you guys have a tech person there to help you?
Yeah.
Good. I'll need to get his or her name and email. That would help me at some point.
Okay.
Do you want it now? We can give it.
Sure.
No? Okay.
I think I'm in. You should hit.
Okay.
I think I sent you the email.
Okay, sweet.
And it should be the Friday one.
Great, thank you.
It's just mislabeled.
Well, the latest one I sent, I think, is right. So it really is Tuesday. I'm pretty sure. I had it wrong originally, but if I just sent it, it should be. There you go. Gotcha.
Mm-hmm.
All right, you're in. So can you see the screen now?
Yes.
Great. All right. So we have the super. Thank you. So the original quadrilateral is ABCD on the left. It's orange, and the image is LMNO, and it's indigo. So that's image. So we want either a translation or a reflection or a rotation first. So what should I do? What should Walter do? Walter's going to do this.
Translate D to O.
Okay, Walter, would you do that, please?
Yeah. Alright.
This is epic.
There's. I can't move this. Oh wait. Oops, sorry. Okay.
It's the one-dimensional. The vector's under the one-dimensional thing, which is the line. So it's the third from the left, down there. Yeah, get the vector there. Oh, did you get it? Yeah, there you go. Okay, you got it. Okay, who answered? Which one of you, Ryan or Logan, answered the first question?
I did.
I
Ryan.
being
Ryan?
Ryan. Okay, so Logan, what do we do now?
You rotate the shape around D so
Okay.
that C touches in.
Okay, and I need an angle.
Like 38 degrees ish.
Well, I use the letters in the there. Yeah,
Oh.
right.
CON, yeah.
Okay, good. Yeah, C. What did that? Yeah, C1 prime. It called it. Okay, ON. Right, that angle and a direction. Clockwise or counterclockwise?
Clockwise.
Clockwise. Okay. So Walter is doing that as you talk. Yeah. All right. So there's a problem. So undo that and try it again. Is the angle correct? And you have to get rid of the 45. Yeah, right. There we go. All right. And thank you. And now what do we do?
We reflected over line segment ON. I think those are the
Yeah.
letters.
Yeah, that's a good idea. Yeah. Walter is actually drawing the line, so we're sure we got the right line, which I didn't do last time, and there we go. Okay, now take the move tool. Go to the move tool and move your original around. I think you want to move the original. Yeah, and see that it always winds up on top. So Walter did a much better job than me. Thank you, Walter. Great, well done. Okay, you can close, don't save. Good. Okay, now I am going to request control. Let's see if that works. I'm going to try to get my screen to show. Yeah, you stop sharing. There we go. Thank you. And then I can share my screen. Yeah, so you can share your screen, you can share a document, or you can share a whiteboard. And we discovered last time that if you share the whiteboard, you can write with a pen, but you can also type using text, so that's nice. So I'm going to share my screen. Connecting. You need Adobe. Oh boy, it didn't ask me that. Is that the add-on that you got asked for? That it said you needed, Walter?
Yeah.
Yeah. Okay. So I'll say yes. Although I don't think. I don't think I can say yes. Oh.
So
All right, you know what? I'm going to go back to Blue Jeans. I'll figure this out later. I'm just going to share my screen through Blue Jeans, which works fine. So I'm going to go back to Blue Jeans. Here's the Blue Jeans room. And I'm going to share my screen through that. So I can do that here. And I'm going to open GeoGebra and make sure you can see it. Okay, so are you all back in Blue Jeans and can you see my screen? Blank screen.
Yes.
Great. All right, the next thing, we've done these isometries, and isometries are distance preserving transformations. But there is also, and that's related to congruence, obviously, but there's something called a dilation. And a dilation works like this. So I'm going to make, and you'll see now, this is the polygon tool. So I'm going to make a triangle. And the way it works, as you can see, it says select all vertices, then click the first vertex again. So here's one vertex, 2, 3, and then I have to go back here, click, and now I have polygon. If you want to see this actually, let me show you this. If I go here on the right side of my screen, there's this little arrow, and if I click that arrow, it gives me other perspectives. I'm in geometry now, but if I go into algebra, what it does, it gives me this coordinate system, which I don't necessarily want, and that's under graphics. So right now it's got the axes. I can just click on that and the axes are off. But the interesting part is it shows on the left the objects. So this now consists of 3 points and 3 segments and the polygon, poly 1. And a convenient thing about this is I can show or hide things. Right now, these are shown, but if I, for example, if I click here, then that hides that point. So that's useful when you want to hide a whole bunch of things or you want to tell what certain things are. And this I'm not sure of. If I want to show the label, yeah, I can also just click on it and I can show the, yeah, maybe I can show the label of all 3 at once. That's what I'm going to try now. So I want to show the labels, so I'm going to do A through A, B, and C here. And now, let's see, if I just click, no, I have to right click. So all 3, and now I say show label, and it shows me all 3 labels at once, which is kind of nice. And now I go back here and move them around. So here's triangle ABC, and the nice thing about this triangle now, of course, I can translate the whole triangle, or I can move the individual vertices. Or I can pull a vertex. I can pull a segment is what I meant. I can pull a side. Okay, so you can move the triangle. All right, a dilation requires a point. See, if I go here to this is our transformation tool. Ryan and Logan, you'll get used to this. You know, in the beginning we practiced it, but you're seeing it quickly. Here's dilate from a point. And it says select an object, then the center point, and enter the factor. So I need a point. So I go to my point tool here, and you notice that under the point tool, I can have a point on the object. I can get an intersection, a midpoint, and there's even complex number. But right now, we're just doing a point. So I'm going to make a point here, and that's point D. And now it said dilate from a point, select the object, and then, yeah. So here's the object, my triangle, and then I select the point, and now it's asking me for a factor. And what do you think it means by factor? One of you. What does
Like,
factor mean, do you think?
A factor of the original size. So like, if
Yeah.
you.
So pick a reasonable factor that'll leave it on the screen.
3.
Three.
Or, yeah,
All
or
right.
2. 2 or 3.
So here's 3. We'll say okay. Okay. So let me move this in a little. You know what I did? I forgot to go ups. There. I forgot to go back to the move tool. I want to move this a little closer and down so we can see it. There we go. Okay. So what happened? What happened exactly? Yes, it's 3 times. Well, first of all, you want to see if it's 3 times longer. Okay. That's, let's see if we can do that, if we can confirm that. So there's a measurement tool, and the measurement tool is here. I think. Let's see. Distance, yeah. So a distance in centimeters is here. And if I want to select 2 points or a segment or a polygon or a circle. Okay. So let's select this segment. And it has 3.76. And this is 11.29. And I'm going to move them so we can see them. I want to move the labels. There we go. It forms, let's see, when I do this. Oh, I have to click the segment first and then, yeah. And then when I click, it has a hand. And that hand is what lets me move the label. And it would really be nice to calculate, wouldn't it? So I'm thinking about, can we do this divided by this without in this software? And I haven't done that. Walter, you have an idea?
Not really.
Or do we have
no.
to think about this some more? Probably a way to do it. Let's see. Area, create list. Okay, I don't know how to do it right off the top. But if you have a calculator or you divide this by this, do you guys have something that you can use to do that?
It's 3.
It's 3. Yeah. Okay.
It's 3.
You believe it. I'm gonna see if we can do that within the software at some point. But okay. But so yes, it's 3 times as big. What about the angles?
They're the
They're
same.
the same.
Okay. So corresponding angles. But I have another question, which is, how is the dilation done? What did it do? So it didn't just, this is not in an arbitrary place. Yes, it's 3 times as big, but it's not in an arbitrary place. I mean, if I move this, it's going to move that too. So what actually is being done here?
Is there a line being drawn from D to the original, and then it kind of marks the same place on the enlarged polygon?
Okay, so tell me what to draw. I want to draw some more lines to make this obvious. Segments, actually. So I'm going to say segment. What segment should I draw to make this obvious?
One from D to the enlarged one.
Well, give me a point. I mean, we've got. Give me a point. Yeah.
D to B prime.
Okay. So we're going to draw from D to B prime. And that segment is got a name. So I want to show the label, just so I don't get confused here. It's segment D. It showed it automatically. So that's segment D. And I want to measure segment D. So that's here. Yeah. Oh, that's nice. Isn't that nice? So it says D is, I probably could have right-clicked and say show value. And so D is 11.99. Okay, and I want another segment that I can use that will give me a measurement as well. That will show the 3. I want to show the 3 in some way. So what other segment should I do? I want to do a segment.
Oh, from D to A prime.
Yeah, but I want to do the same kind of thing. I want to show the 3. Just okay. So I've got from D to B prime. That's 3 times what?
The length of D to B.
Okay,
D to B.
so let's do that. So we're gonna do D to B here. All right, and that's E. And let me see if I right click. No. So we're going to use the measurement tool and do it on. Now I have to be careful because I have to I don't want oh, here we go. See, if I hold it, it shows me segment D and segment E, and the one I want is segment E. So I'm going to go down, I think. Oh, it doesn't do that. Oh, there. I got E. Okay, it tells me which one I have. All right, so that's E. So E is 4. Okay, so we can see it's off by 100th, right? But it's 3 times as big. So what does this dilation do to any point? For example, let me do this. I'm going to make a point even inside. Or on. I'll do it on. So notice that when I move, I want a point. And when I move here, it tells me that I'm now in the triangle, and now I'm on the triangle and the segment, the side. So I'm going to make it on the side here, okay? So here's a point. It's called E. And I want the image of E, but I don't want to use the dilation. Let me think for a second. No, just tell me how to dilate E. What do I do? What do I do to get E prime, the image of E?
You draw a line DE.
Okay, so I draw segment DE. So I go here to segment, and I go from D to E. Do it right. Let's try that again. I didn't select the tool. Segment, hello. D to E. Okay, so I've got that.
The line, not the line segment.
Oh, the line. Hello. Sorry.
Yeah.
Okay, so I'm going to erase that and do the line. There we go. The line from D to E. Yes. Nice.
Then
Thank
where
you.
where this line hits A prime, B prime.
Okay.
I guess you could call that E prime.
Okay.
And E
So
prime
I
is the
need
dilation.
to label that point. There are 2 ways to do it. One way is let's just for variety, I'm going to use the intersect tool. And the intersect tool says I need to select 2 objects or click directly on the intersection. But just to show you that I can select this object and this object, and there's our point F. So F is the image of E. And if I want to change its name, I think I can do this. Yes. Notice that if I click on that, it says rename. So if I go down here to rename, and instead of F, I want it to be E prime, I can do that, E prime. All right. So that's the image, and what Walter is saying correctly is that if I took the distance, which I'm not going to do now because we're almost out of time, if I took D E prime and divided it by DE, I would get the number 3. And that would work even if I took a point inside. If I want the image of a point inside, I would do the same thing. I would draw the line just as Walter told me, and then go 3 times as far along that line, and I would get the image. So that's how a dilation works. Okay? Logan and Ryan, any questions? Are you clear?
So far, yes.
Okay. Sounds good. All right. Then we don't really have time, but I'll just start it just to show you. Now, if I open, maybe we just have 2 minutes left, so I have to do this. No, I don't want to save the changes. I want to open Tri-Similarity 3 and just give you a sense here. So here are two. Here's our orange, which is our original. And I want to show the labels on this. So that's B, and that's A, and this is C. And what I'm going to want to do, and I think we'll just have this, we'll start this next time. And at that point, we can share screens, so you guys will be able to, we'll figure out how to do that. So you guys will be able to, everybody will be able to share their GeoGebra screen. So the challenge will be, just like the congruence, this is similarity. So we confirm similarity by, what do you think? By what?
Overlapping?
Well, I need a sequence of transformations. And the transformations will not only be the three we used before, which are translation, reflection, and rotation, but also
Dilation.
dilation, right. So that's going to be the challenge, is I want to make the orange one map to the indigo one by using a sequence of dilations and reflections and rotations and translations. Okay? And Walter, I have a hard question for you. You listening?
Yeah.
Okay. And the hard question is, how many dilations do you need? Is one enough? And secondly, does it matter where the dilation is? In other words, if I can do it in a sequence where the dilation is first, could I also do it in a sequence where the dilation is last? Or does it matter? That's how do you make that question precise? So in other words, can I say that it's always possible to do it in a sequence, in one dilation and some other isometries? And for example, can I always require that the dilation be first, or can I always require that the dilation be last? And I don't know the answer to that question. Okay, so think about that. Okay, guys. I will send Ryan and Logan. I'll send you an email, and I want you to reply, hopefully sometime in the next 24 hours, with what times work for you, where we three can meet, and I can catch you up. Okay?
Great.
Okay. Thank you. See you next time. Bye.
Thanks.
Thank you.
Bye.
Hey, Lou? Lou?
Yeah. Let me get back here. Yes.
It is. Hi, guys.
Hi, Miss
She
Sobe.
said hello just as.
I don't know.
Oh God.
What happened?
No.
Okay, never mind. It's fine.
No,
it's fine. If we needed to know her, we would have
Guys.
already known about her.
I'm
Yeah.
always lurking in the background, guys.
Okay.
Oh my God.
Fort Worth, you guys need to log off, please.
Yeah, Fort Worth, could you log off?
Like I had to get back into the mindset of geometry.
Ryan, Logan, can you log off?
I don't think it'll get different.
Yeah.
It'll
I
get
don't
really
think- I'm going to stop the
Be nice.